Okay, just my last one for this evening. This one is when you have sine of 2 theta equals minus a half between 0 and 2 pi. We've seen the ones where it's just been theta. I just wanted to give you the technique for when it's 2 theta. In the textbooks and some teachers let that equal x. I don't. I just widen my view and have a look at it. The first thing you need to do, like we always do, is negative. When is sine negative? And we know from our circle, I'll just draw it quickly here, all stations to central, or as you guys say, all students take chemistry. Sine is negative in quadrants 3 and 4, here and here. Quadrant 3 and quadrant 4. So we straight away know that we're only dealing with quadrants 3 and quadrant 4. A half. Well, you should remember these little triangles. That's 2, 1, 60, 30, root 3. So sine of what gives you a half? Remember, we're just finding the value we're going to be working with. That there is opposite over hypotenuse, which is sine of 30. Remember, 30 is pi over 6 is equal to a half. So quadrant 3, quadrant 4, and we're looking at pi over 6 or 30 degrees. So that's before we even start. And again, we can have a look at the graph as well. So here, the problem is 2 theta. Well, let's just have a look at our circle, and we're going to ignore the 2 theta. But what we're going to do with that is we're going to use that as a multiplier, and you'll see why at the end why we do that. We're going to have to double our domain. So this now becomes theta less than or equal to 0 less than or equal to theta to 4 pi. Now just a note, if you had minus pi to pi, you have to times it all by 2. So it would be minus 2 pi to 2 pi. So that's just having a look at that. We have to double it. If it was 3 theta, you have to triple it because we're going to go big and then we're going to shrink it back down. It's a good way to look at it. So now we know that we have to find the solutions first in 4 pi, which is once around and once around again. And I'll show you those little tricks as well. So let's have a look. We're going to ignore the 2 theta until the end. Now, like you find when I do calculus, I don't use all these little shortcuts. I leave it there and just remember it. So let's have a look here. Theta, 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 theta. And we're going twice around. So 0, 90, 180, 270, 360. Now I might draw this really big actually, so we can have a really good look at it. Because I think it's very important we really understand this. Now you guys should be so brainwashed into drawing this continually. So let's have a look. 0, 90, 180, 270, 360. Now remembering we're doubling it to 4 pi. So we'll just do, remember we're only looking at quadrants 3 and 4 because sine is positive only in these two and negative here. So let's have a look. When we go round once, because that's to 2 pi, 3 pi over 2, pi and pi over 2. So we're looking at only here and here. Now that's just round once. So we write 2 theta, remember 2 theta, ignore it to the end, it's just there, don't touch it yet. 2 theta will be here, remember when we go this way, it's 180 plus theta, and this way, keep on writing it there every time. So here we know that it's 30. So in this quadrant, it is pi plus pi over 6. Remembering fractions, make that 6 over 6. So 7 pi over 6 is one solution in quadrant 3. Let's have a look at quadrant 4. Now this is still with 2 pi. This here is 2 theta is equal to 360 minus theta, or 2 pi minus theta. So we'll do it like this. Now, what's your denominator? It is 6. So to make that, it will be 12 over 6, which is 2. And we get 11 pi over 6. Now that's only in the once around. Now we have to go twice around. So we'll write the solutions here so far. 230 is 7 pi over 6 and 11 pi over 6. But now we have to go around again. Now I like doing it like this. When we go again, it's this. Now this here is really pi over 2. This is 2 pi over 2, which is pi, 3 pi over 2, 4 pi over 2, which is 2 pi. So when we go around again, this will be 5 pi over 2, 6 pi over 2, which is 3 pi, 7 pi over 2, and 8 pi over 2, which is 4 pi. And that's my 4 pi. So you just go around again, remembering it just repeats and repeats and repeats. So I don't want this one, I don't want this one, I want this one and this one. And if you have a look, that's 3 pi plus theta. This one is 4 pi minus theta. So going around from 2 pi to 4 pi, I get that 2 theta is equal to 3 pi plus pi over 6. Now 3 pi, if I make it a denominator of 6, will be 18 pi over 6 plus pi over 6, which is 19 pi over 6. This one will be 2 theta is equal to 4 pi minus pi over 6, which is 4 will be 24 pi over 6 minus pi over 6 is 23 pi over 6. So that's just 2 more solutions because I've gone twice around. So I've got 19 pi over 6 and 23 pi over 6. Let me just make sure I'm on the right track. So now we can deal with the let's have a look. That's correct. So now let's have a look at the 2 theta. So we can probably get rid of all that now. And let's have a look at, we've got all those written there, which is nice. And now this is what we do with our 2 theta. So I've got 2 theta is equal to 7 pi over 6, 11 pi over 6, 19 pi over 6, and 23 pi over 6. So now I can deal with the 2. That's 2 theta, but I only want theta. So you divide everything by 2. Now you can see that's shrinking it back to 2 pi. If I didn't have that, I'd only have that, and I'd only get to pi. I wouldn't have these ones. That cancels out. Now again, we use our fractions. Let's just deal with this one. Divided by 2, which is 2 over 1. And that's the same as 7 pi over 6 times 1 over 2. Because you're dividing it by 2 is pi half. And so we get 7 pi over 12. As we do the rest of them, we get 11 pi over 12, 19 pi over 12, 23 pi over 12. So our solutions are going to be 7 pi over 12, 11 pi over 12, 19 pi over 12, and 23 pi over 12. And that's it. Nice and easy peasy. Have any questions? Again, you can either email me or you can write at the bottom of my video. Hope that made sense. We'll do some more a bit later. Bye now.